And the class before that also I finished up chemical reactions and decomposition and double decomposition. 2 classes you have missed. You're telling me 1 class only? I'll smash you. Where are the other children? Tell Abdullah. Where are the other children? Huh? Why you don't know? They're all your friends now on WhatsApp and others. Don't keep on talking or what? किधर है वो बच्चा दूसरा बच्चा? कौन सा? 11 बच्चे हैं मेरे क्लासरूम में. हाँ? 5, 6 और 5 बच्चा है आने का है. चलो पास. Have you finished signing all of you? There are the girls. Pink t-shirt, red t-shirt, whatever, brown t-shirt. Huh. I'm coming.
It's like a spiky thing on the floor. When you step on it, it shoots spike and spike. Eyes was here. This is the eyes was here. I was walking like this. Basically, I stepped on it, and there were no lights.
So they have come. 11 of them are there, no? 11 or 12 are there in the class. That girl is there. Another girl, Trisha. Who's Trisha?
How much has it come to a lot of classes?
She's?
She has not come to a lot of classes.
She's out of touch.
I don't.
Where was she sitting down, Trisha?
She had only up for 2 classes.
She's left.
She had just joined it.
Yeah, these are all gold press children. These are all gold press. 3 of them are gold press children. So they will not come. Gold press is carrying on. They're still having school. Saturday will not come because they're having school. Anyway, that's not bother. I'll continue. So I did last time water. And now we come to solutions, correct? Now, what is the difference between a solution and liquid? So let's say liquid. And what is a solution? Can anyone tell me the difference? Are they the same? Are they different? Huh? Can you tell me the difference between liquid and a solution? Why would I call this a solution? Why would I call this a liquid?
It is a state of matter and it's in a pure form, and solution is a mixture of a liquid and another solute.
And
the liquid will be the solvent and the solid or the liquid will be the solute, which
mix it up and then you get the solution.
And what do you say? What do you say?
You have to mix it up.
With what? You confused. First, tell me what is the meaning of liquid and what is the solid?
Liquid is a state of matter.
Okay. What solution?
Solution is a mixture of a liquid as a solvent and a solid or a gas or another liquid.
What is that called?
Solute.
What is the difference between liquid and solid solution?
Like liquid is state of matter and solution is the homogeneous mixture of
It is a
homogeneous mixture of solute and solvent.
Okay. Any other difference? Any other definition? You had your hand up now.
Yes, but I was saying,
What is it? What is it?
I was going to say that solution is a mixture of water
Okay. So, in other words, liquid is a state of matter. Okay? Because we know that matter can exist in the solid form, liquid form, and in the gaseous form. So, liquid is a state of matter. What is a solution? Solution is a state of matter, but which contains two substances, solute and solvent. If it doesn't contain a solute, if it doesn't contain a solvent, it is not called a solution. So what is a solution? A solution is a mixture of solute and solvent. All right. Now, so that means if it contains only one solute and one solvent, that means two components, it is called a binary solution. It's called a binary solution. If it contains three components, means two solutes and one solvent, it is called ternary. If it contains three solutes and one solvent, it's called quaternary. Is this clear? So as the number of components keep on increasing, the number or the name will change. But what is it that is changing? What is increasing? The solvent is increasing or the solutes are increasing? Only the solutes. Only the solute. The solute, the solvent can be water. So we will call it aqua solution. Okay, aqua solution means the solvent is water, the solute is something else. Aqua. If it is alcohol, it is called alco solution. Alco solution because the base is alcohol, the solvent is alcohol. If it is petroleum, it's called petro solution. By petroleum, when we have to wash our clothes, dry cleaning, then that time we have used petroleum as the solvent. So that is the different types of solutions. Now, the main differences or main categories of solutions will be solid, where the solute is solid, the solvent is solid. How can two solids have liquid state? They have to be melted. They have to be melted. Okay, so therefore, suppose we are preparing, now see, gold. Now, all of us are wearing gold. But this gold that we are wearing is not pure. This pure gold is 24 karat. And pure gold is very, very soft. You can't make anything out of that gold. But if you have to harden that gold, you have to use a lot of other components. Other components will be a little bit of copper, a little bit of silver. Now, can I see copper in this? Can I see silver in this? No. Because copper has been added, a piece of copper has been added, a piece of silver has been added, and a piece of gold has been added. 22 parts. 22 parts of gold have been added, 1 part of copper, 23, 1 part of silver, 22. Ultimately, becomes 24. And all of them are melted. And when they are melted and they are stirred very well, they get into each other, they form a homogeneous mixture, then that is hardened, and then you make your ornaments. Okay? So they have to be a very homogeneous mixture. Homogeneous means you cannot see where the copper is, you can't see part of silver, it just looks as if the whole thing is a gold. That is solid solution. Then we've got liquid solution. Can you give an example of liquid solution? Liquid solution. Remember one thing, solution has to be homogeneous. And so is oil and water homogeneous? That you remember. Basic things are water and milk. Yeah. If you strain the milk and take out the cream, then it becomes full white. Or alcohol. Alcohol and water. So this is liquid. Okay? Now then comes liquid gas. Your Coca-Cola. Liquid gas. Gas is inside liquid gas. Gas. Gas is what now? Huh? Air. Or even your sprays. Okay? So that's liquid. Alright? Now, if you have got two liquids to make the solution, which is the solvent and which is the solute then?
The one that is taken in Cocoa.
Yeah, that particular solution, that particular liquid, which is a large quantity, that is a solvent. And alcohol, and what is the smaller quantity? It's said to be solute. Okay, so there's a little joke, they said, "Arey, I'm drinking rum with water and I get drunk. I'm drinking whiskey with water and I get drunk. I'm drinking gin with water and I get drunk. The common factor is water. I take out the water and I drink everything alone without any water." Alright? So that is it. So now you know that that particular component, which is in small quantity is a solute, and that which is in large quantity is the solvent. When we have liquid solution. Correct? Okay, now. So that much we have finished. Then we go to the next part. Always a solution has to be homogeneous. Be it gas, liquid solid. Okay. Now, if it's liquid solid, there will be no solution of liquid solid. Why? There will be no solution with liquid solid. Because the solution has to be homogeneous. So if you put a solid which is not soluble in that water, then so even if you are using solid liquid, that solid has to be soluble. That solid has to be soluble. Salt and water, sugar and water. Correct? That is solid and liquid, but the solute has to be solid. Because the key word is solution has to be homogeneous. Then a solution is a true solution. What do you mean true solution? When you look at it, it looks as if you're just looking at one thing. You don't know that there are so many other components inside. Sugar is inside, salt is inside. You don't know unless you taste it. Correct? Why? Because it's a true solution. Why is it a true solution? Because it's homogeneous. Why is it homogeneous? Because the particles of the component, the particles of the solute are of the size 10 raised to minus 10. 10 raised to minus 10. That means 1 upon 10, 10 zeros. So tiny. That means it can't be seen by the naked eye, it can't be seen under the microscope. Correct? So a true solution has got particles in it which are of the size 10 raised to minus 10. That means in a true solution, the main property, it is homogeneous. It looks like one, homogeneity, it looks like one solution only. It is having particles of the size 10 raised to minus 10. It cannot be filtered. Particles are so small they pass in the filter paper. There is no sediment. There is no filtrate. It cannot be filtered. These particles do not show, or they do not scatter light. They do not scatter light. What means scattering of light? I'll explain to you. And finally, this true solution, when you keep it like that, it will remain like that, it will remain stable. You'll never see after 2-3 days that the particles have settled down. Salt and water has settled down and the solvent is above. No, it is always stable. The particles will always be floating, never they will settle down. Now, what's the meaning of scattering of light? I'll tell you. Suppose you have closed a room for 1 full month. And after 1 month, you come. And through the peephole, you pass a torch, light. What will you see? Can you imagine what you'll see? What do you see? What do you see? If you pass a light to the people, what do you see?
Yes.
What do you see? Loudly. You a beam of light, a beam of light, okay, a beam of light, and in the beam of light you will find particles dancing. That is the dust particles, correct? That is called Tyndall effect. In other words, those particles are reflecting the light that is being thrown on them. Correct? In the case of blue solution, if you keep a beaker with true solution in it, and you pass light through that true solution, the light is not going to pass through because no particles are going to absorb and reflect. There are no particles, the particles so small they will not. So Tyndall effect or reflection of light is not shown by a true solution. This clear is the properties of a true solution. Now we come to what is a saturated solution. Have you heard of saturated solution? What is saturated solution? Saturated, or how will you prepare a saturated solution? Yes, Vivian. How will you prepare a saturated solution?
You salt and
Huh?
water. Salt and water.
How will you prepare it? Salt and water. Okay, give me that is preparation of a that is salt solution. Give me saturated salt solution. How do you prepare?
Continuously put salt
Yeah.
in it until no salt and salt.
Till no salt means you have a beaker. Suppose you've got 10 ml of water and you're adding salt. You're adding salt. You're adding salt. And you keep on adding. At room temperature. You're adding. Okay? Till a time comes that you find some salt settling down. No matter how much you stir, that salt is not going to get into the intermolecular spaces of water. You have prepared a saturated solution at room temperature. At room temperature. That is a saturated solution. When a particular solvent cannot take in any more of the solute, okay, at room temperature, and some of the solute is found settled at the bottom of the container, then you say that you have obtained a saturated solution at room temperature. Now, how will you prepare now what happens is when you cool that saturated solution, when you cool it, you prepare it at room temperature, okay, fine. Now, why am I saying cooling it? Because it means stirring and stirring and stirring. So you create some little bit of heat. So you just keep it on one side and let it cool down. What do you think will happen?
So, the particles that are not dissolved will be dissolved.
No. I'll tell you one thing. I will filter it. I'll filter that solution, take out all those particles which were undissolved. And now I have a clear filtrate. And I'm going to heat that filtrate for cooling. What do you notice?
Crystals will form.
Yeah, tiny little crystals of salt will come out. You add the solution as cooling, it's throwing out the crystals, which got caught up in the intermolecular spaces of that liquid. Okay. Now we come to supersaturated solution. What's a supersaturated solution? Can anyone
We
tell me?
change the temperature.
Huh?
When you change the temperature.
When you increase the temperature, not change, increase. Changing which you can cool it also. So what you do that same saturated solution, you found that there was something lying at the bottom. Correct? So what you do that same solution, you took and kept it on a beaker, on a tripod stand on top of a burner, and you're stirring. You will find that liquid has dissolved. Then you add more salt, then you add more salt, then you add more salt and more, and again you will come to a point where no more salt is getting dissolved. You have come to a supersaturated solution. So what do? You take it down, you immediately strain it. You take out all the undissolved particles which have been caught up in the filter paper. And the filtrate, you will keep it Cover it up so that no atmospheric dirt gets into that solution. Then close it up, tight. As the solution is cooling, and it will cool because you heated it. If you cool, you find crystals, clear crystals of salt forming. And if you have to put a thread hanging and the thread fit into that solution, salt crystals will stick onto that thread. So when you put it up, you find the thread with all crystals and crystals of salt stuck on that thread. Is this clear? That's how you prepare a super saturated solution. You got that much? All of you will read the please. Then I will go ahead. Read! Again, you didn't let me get it.
On my higher projects, the after that, so I'm students are ready to be.
Those who got graph, leave the volume. This is rubbish. Leave the volume. At home, because your mommy is studying chemistry, your daddy is studying chemistry. You need to put it home. How many are still reading? Finish reading? Finish reading, all of you? You have finished reading or you still reading? You just started reading.
Yes.
Have you finished again? You have to finish this year only, yeah? Okay. Now we'll just take a break and continue reading. Now, first of all, what is a dilute solution and what is a concentrated solution? Can you tell me what you understand by dilute solution and concentrated solution?
When like a solution has more amount of solute, so solvent, it is considered dilute, and when it has less amount of solvent, it is considered concentrated.
Yeah. Who has not understood this? Raise your hand. You didn't hear what you were
So like sorry, it has less amount of solute, it is a diluted solution, and when it has more response.
Yeah. So what is a dilute solution? I'm going to show you by finger. When the solvent is large and the solute is less, that's a dilute solution. And when the solvent is less and the solute is large, it is a concentrated solution. Correct? So the term is given to the quantity of solute added. If the solute is added less and the solvent is more, dilute. If the solute is more and the solvent is less, concentrated. Now, how will we calculate? We have to calculate that. Calculation of concentration. The word concentration means immediately I have to find out exactly how much of solute is present in that solution. Solute present in that solution. Okay. So there are two ways of finding out. There are two ways. If it is there are these are two problems which have to be okay. Now this is to find concentration of solute. If there is solute, what is it? Concentration of solute, no? Concentration of a solution. The solubility of solute. This is concentration of a solution. Concentration of a solution. Solution. Now, there are two ways. First is mass percent, and second is volume percent, percent. Now, why do you think there are two words, percent, 100? But why mass here and volume here? Don't look at the book. Why do you think they use mass here and why they put volume here? Why? What idea did you get? What idea did you get? Why they put here mass and then they put volume? Why? You
Mass refers to like when solute is solid and volume is like when solute is.
yeah. So here, mass is when you have solid, liquid. Solid, liquid. Solid is your solute. Liquid is your solvent. And here when it is liquid, liquid. The solute is liquid and the Solvent is also liquid. Now, how you will find out? Actually, the definition is we have to find out how much of solid, solute is present in 100 grams of solvent. Or I would say, how much grams of solute is present in 100 ml of water. Okay? This is 100 ml. And here, how many ml is of solute is present in 100 ml of water. Correct? So here what we have is, mass percent will be mass percent, mass of solute upon mass of solution multiplied by 100. Quantity of the solute present in the quantity of the full solution. Okay, I can also write this down as mass of solute plus mass of solvent. Correct or not? Solution contains both. Okay, multiplied by 100. And second one here, second one will be volume of solute upon volume of solute plus volume of solvent multiplied by 100. Is this clear? This is the way you have to do it. This is for what? For concentration of solution. This you have to remember. This formula is to be remembered when I ask you or give you a problem on find out the concentration of a solution. Any difficulty? No. So now, all of you have got the thing with you, Dalal, Nana Dalal, volume, the thing with you, volume. Have you got that problem with you? Have they given you this in your volume? Yeah. So read now from the very beginning up to concentration of a solute. Up to here you will be in your volumes. All of you got volumes, no? So read till here. From the very beginning, from where I taught you today, that is solutions up to this point. Okay? The rest part of it I will do next lecture. Okay. Next time you please come with your volume. Read properly, please. See how they work the problem solves out. And if anyone does not know how or doesn't understand, ask me. I'll come and explain to you. Okay? What? You read?
I might get the solutions back before they get
What about now what I explained to you is
concentration.
how to do the problem solve. So you know how to do. If I give you any problem, will you be able to work it out? Let's wait for some time.
The volume percent regarded in mass of solid upon volume of solid and solid.
Uh-huh.
Then the volume percent in the word regarded in mass of solid upon volume of solid and volume of solid. So, is that an error?
It's an error. It's an error. Let me see. Look at the volume.
Mass of solid. Mass of solid.
The word mass you cut out. It's volume. Are you all following my explanation? Any difficulty? Everything clear?
That's clear. This is clear. This is like a socket.
Only if you finish reading, then do the question answers at the back of the chapter.
Answers are already given.
Huh?
Answers are already given.
Yeah. So don't look at the answer. Okay. You work out. Here, page 44. No. Volume. I'm thinking volume. Give me. Look at that volume, huh? The volume. Come, give me a volume. Give me a pen. Your book, pencil, give me. On page 52 of your volume, no, you can't do anything in a while because I can't explain that to you. So don't do anything. Then in that case, after you have read it, look at all the question answers and learn them. Look at all the question answers. You have got no volume, so how can you learn now? All the question answers are there. Learn them. See it from your book. Learn,
We read like
read and learn. Understand. Read and understand it. But yeah. Learn it. Read and learn. All the questions up to where I have taught you. Ian, why are you sleeping? Where's your book? Keep it up. Keep your head up and read. Keep your head up and read. Sit up straight and read.
the answer for the first one is wrong.
Right, come here.
Like for the first
There, this one.
yes.
This one.
They are talking about this. They think of condensation.
No, first answer is wrong. What exists in all three states? Discuss. How will you get the answer? Discuss the answer, not really. Discuss the answer. Water exists in all three states. Discuss the answer. How will you what's the answer? Water exists in all three states. Discuss.
Water can be ice, water can be water,
Huh?
and water can be steam.
Yeah, so tell us how.
By cooling it, relieving it, then by boiling
Tell us how. We'll discuss it. And this is state. As a discuss. How will you discuss? Water is liquid state, solid state,
Like water
liquid
is a
state,
liquid.
gaseous state. Yeah?
Water is a liquid in ordinary conditions.
Yeah.
And then heated
At room temperature. And what is the pressure? Normal temperature?
normal pressure, normal temperature.
What is the normal temperature? Okay, normal temperature we will say it fluctuates. What pressure? 760 mm. Correct? Mm. At that temperature, water is liquid. Alright. Then at 0 degree centigrade
Water
and 768 mm pressure, it is solid. And 100 degree centigrade and 760 pressure, 60 mm pressure, it is gaseous. Steam. Write that answer down for the very first answer. That answer is wrong. That will give it to you in the book. Water exists in all the three states. At room temperature and 760 mm pressure, it is liquid. At 0 degree centigrade, 760 mm, it is ice. At 100 degree centigrade, 760 mm, it is vapor. You're not ready now? I gave you the answer just now, no? What were you doing? Water exists in all the three states. At room temperature and 760 mm pressure, it is liquid. At 0 degree centigrade, 760 mm pressure, it is solid, ice. At 100 degree centigrade and 760 mm pressure, it is vapor, steam. Don't say steam, say vapor. Don't say steam, steam is very different. Say vapor. You wrote? Have you learned? I can ask her to do some problems on the board. This type of problem I will do on the board. Yes? All of you? Okay? You is ready to do the problem on the board? Okay, so what we do now? You will just about that board. Go you on the board. Two point five. Okay, just take it. I take 4.5 liters of spirit. 4.5 liters of spirit is present in not take 2.5 liters, take 2.5 milliliters. 2.5 milliliters. 4.5, sorry, 4.5 milliliters. 4.5 milliliters, ml. Spirit is present in 4.5 milliliters is present in 1 liter. In 1 liter of water. Calculate volume percent. We calculate volume percent of concentration of the solution. Volume percent of concentration of the solution. Okay.
Shall I write the formula?
Yes, of course, of course, of course. Just get me a bottle of water. Please. Yeah, ask Vijay one bottle of water. This one bottle of water. Thank you. You work it out. You work it out. How are you doing it?
Dividing.
If you add up 1000 and 4.5, add up properly here in the corner, you are still moving. Add it up properly.
Just remove the decimal or
Is it right? And how?
I remove the decimal on here and here both sides. So basically I multiplied them with 10.
That's one more. In other words, you are adding 1000, correct? And 45, no?
No ma'am. Ma'am, I first added them, then there was one decimal place, then I had multiplied them with 10, both of them. So they are like, what is 10,045 and 45. I multiplied them both with 10.
Okay. How many you got 5? How many you got 5?
And I divided both in 5.
Is it correct? Is it correct? Why not?
He has to do into 100 also.
Ah, have you put the into 100
What?
volume of solute upon volume of solvent plus multiplied by 100, no?
Percent has that.
Percentage बोल रहा है ना? You have to change the whole thing now.
No ma'am.
Yes,
Only
add
one zero
up.
added.
Okay.
Yes.
Huh?
The calculation is very good.
Okay. Stop it at 0.44. Approximately we take it. So your answer is what now? See, that is the answer. 0.44 is the answer. Is equal to how much? What's the answer?
Zero.
Is it correct? Huh? It's not in the book. That's not in the book. Is this correct? 0.44 multiplied by 100. Is it correct? Is the answer is correct?
By 10%.
Huh?
यहाँ पे मैंने डेसिमल निकाला ना पहले स्टार्ट
0.44 multiplied by 100. Take out the decimal point, no? So it becomes 44, no?
0.44.
Let me see my mathematics.
I guess it should be 0.4.
Is what now? Is that it? You will shift the decimal point and become 44.
Why would I multiply with 100?
Huh?
Why shall I multiply with
Percentage, no?
No, ma'am, I already like.
I didn't know when the very first problem formula has got into 100, na?
Yes, ma'am.
Into 100,
So,
no?
ma'am, this will become 900. I have taken it
No,
here
no.
9.
Ultimately, when you divided it, it was 0.44. Right, 0.44 multiplied by 100. Multiplied by this 100, no?
Yes, ma'am, that's why it is 900 and there is an extra 0
Arey,
divide.
Without doing all this, you got this answer?
No,
Ah.
if I had got that, then it might be more 2 zeros.
From where you got the 9,000?
Because first 9 I multiplied with 100.
From where the 100 came in after, then we told you that you made a mistake. This
Yes,
100
ma'am,
came in
but this
afterwards.
100 is remaining there only. I didn't calculate the 100 anywhere. So it basically becomes 900. This 900 extra 0 to calculate 2900.
What sort of maths you are doing? Is he correct? He's not at all correct. I don't know how he is doing his mathematics. This part of it is correct. This we'll do it first. The volume of solute is what now? Volume of solute is what now? 4.5. Okay? Upon volume of solvent plus solvent is 4.5 plus 1000. Correct? Alright? That is what I'm going to get now. That means the answer will be
I'm into 100.
into 100. Into 100. Correct? Alright. Now what's happening? You are getting 4.5 upon. Let us do simple mathematics. I'm not going to complicated mathematics. 1000 into 4.5. So it becomes 1004.5. It becomes 1004.5 into 100. Correct? Right. So you took out this. You took out this. Correct? So it becomes 45 upon 10045 multiplied by 100. Correct? So what is your answer? You do directly by the mobile. Some complicated, stupid things he's getting. Is equal to 0.4479.
Yes, ma'am, 0.44.
Ah, it is 0.044. I'm taking from where is the x1 0? You're telling me about 9,000. So you are confused and confusing me also. Dada, I know maths. Put down the answer here. Answer is 0.447. Wait. It is 0.44798. Correct. Now, is it for the number should be 0.448. 0.4479, no? So the 9 is 5 and more than 5. So that's 0.448. This is the answer. But what is the unit?
Liters.
Milliliter. You.
Exactly.
You found it multiple by 100 there. 0.44 percentage. Percent. Okay. Have you got that down? Understood this now? See how complicated this thing was? Okay. Take another one. You knew what was on the board. Hurry up, quick. Fast is there. 75 grams of salt.
No,
Please hurry up. 75 grams of salt is dissolved in 75 grams of salt in 3 liters of water. Calculate concentration of the solution. Calculate concentration of the solution. Calculate concentration of the solution. You are doing your work in a book, all of you. All of you do it in a book.
one liters, 1 liter is equal to 1 kg.
Come on, dear. What table are you using?
About 75, about 75.
5. 5 ones are 5. 5 ones are 5 now. So 17 given 5 is how much? 17 given 5 is how much?
17.
7 take away 5 is how much? So then, so 25, no? Huh?
55 or 75.
That is 7 5 ones are 5, no? 5 ones are, so there's 25, no? So then 7 5 to 25, no? So 5 3 is 25. Then 1 for 5 3 becomes 75. Idiot. Work the whole thing out properly. Again you made a mistake then 30, 75. 30, 75 again you made a mistake. 5, 6 are 30. Where's the board duster? Okay. Okay, it means what number? With what number are you dividing 100?
Divided by 3. 100 maximum.
Divide this by 3, no?
Yes.
300, no? Put a top 100 there.
100 upon 40.
And if you 3 4s are 12, 41, 100 over 41. 3 1s are 3, 0, 0 upon 3 4s are 12, and then 3 1s are 341. Then now deal with smaller numbers, no? Yeah. Okay, stop there only. So what will be the final answer now?
2.436.
2 point.
436.
You are supposed to be working at how many decimal places always? 2 decimal places. Huh?
2.4.
2.22 decimal places is equal to work. So that means 2.4. What is the third decimal place?
6.
Isn't 6 5 and more than 5?
2.44.
Yeah. What's wrong with you, man? What's the final answer?
2.44.
Write it down. So long you're taking it to do this one sum. How are they going to finish up the paper? Why are you taking so long? Your brains are frozen or what? Are there any problems solved in the book? Or which one are you doing? What you are doing? This one only. What classes do you want time to be?
250.
Just for this page and the portion
Till 6 o'clock.
all those who have taken social.
Till 6 o'clock.
Yeah.
Look, you're taking social also. So this will have to sit till 6 o'clock. How many of you have taken social? Have you taken social?
No.
Afterwards, you have to close the books down and come back and continue. Sure. Yeah.
Class over. Class over.
Class.
Class over. Class over.
That you know very fast that the class is over.
Because I have
So you're in the kitchen.
general base has to be bigger. जैसे समझते कि 2 मिनट आणि क्या मैंने लिखा ये आप कुछ दिखाई